All right, welcome everyone. Thank you for joining another Integration Quest MuleSoft study group. Today we have Philip. He's going to be presenting on database integration and just had a few things to go over before I turn everything over to him. We appreciate you all joining. If you're live or watching this in the future, we just want to say real quick, just for the people that are live, if your mom and dad would have told you not to do it, please don't do it. Everything's been great lately and everything's been good, but we just like to put that little disclaimer out there just in case. I'm also letting everyone know I was literally just replying to some comments over on the Integration Quest YouTube channel. And I'm so happy to see people over there coming in, commenting, and watching some of these archived videos from all the past Integration Quest study groups. So please, if you haven't gone over there and checked that out, check out either one of these links will get you there, and you can go ahead and subscribe while you're there, so that way you'll get a notification as we put on new study groups. It's free knowledge, everybody. It'd be crazy to pass up on this. I'm all about, constantly training and making sure that we're sharp on our skills. This is a great place to do it, to go over there and check that out. And I communicate with people back. So drop a comment in whatever video helps you and give us ideas if something comes on your mind. We love hearing from you. So today we have Philip in the room. He has had over a year of experience in integration development. He's also a certified MuleSoft developer and has been delivering in projects already. He's been on the Anypoint platform, Anypoint Speedway, a lot of experience. And as we always say, it's not just about the experience. I'm so thankful that Philip is also willing to come in and share some of this knowledge, share some of his experience in this. And we just really appreciate that. That's what it takes. It takes just the willingness to give back, and that's what Philip's doing. So I'm going to stop sharing so that way he can do that. And just everybody give him a nice warm welcome, and thank you for being here today, Philip. We really appreciate it.
Thank you. Thank you. Okay, let me start sharing my screen.
Like I said, I'll keep an eye on the chat for you, Philip, while you're going through. And if you have any questions on the display or anything, just let me know. We'll walk you through it, help you out.
Let me share my screen. Able to see my screen?
Looking good. Yep, you are on.
All right. Thank you, RJ, for introducing me. My name again is Philip, and we're going to be going over databases today and how to integrate them with MuleSoft. As RJ mentioned, I have a background in biomedical studies and integration development now, and I am very curious, and that curiosity has brought me into tech, and keep. I always like to learn. But my friends and family are happy now that we have things like ChatGPT and AI that can answer questions, and I don't have to keep asking why. I always say I'm the kid who never stopped asking why, so I keep going over there. All right. So today we'll be talking about databases and MuleSoft. Our agenda, we're going to ask what is a database, types of databases, how do we use databases. We're going to be going over SQL databases. And then we're going to get into integration with a powerful tool called MuleSoft. And we'll see how we can connect MuleSoft to our database. And then we'll have a demo and a Q&A. All right. So before we get into the nitty gritties of the databases, it's important to understand the history of data history and the storage and how we came into databases. So we're going to start way back and ask ourselves, what is data? According to IBM, they said data is a collection of facts, numbers, words, and observation. Through time, way back since starting on 3000 BCE, we started storing data, because the more data you have, the more information you can get and the more you can analyze. So in 3000 BCE, we had clay tablets in the Sumerian records, 1801. Jacquard Loom came up with the punch cards. The punch cards helped the textile industry because he had templates, and I'm going to show you some pictures of this that helped create the textiles quicker. That way, people wouldn't have to go over them over and over. Let's start with the clay tablets over here. So on the clay tablets, the Sumerian clay tablets were an ancient artifact used by writing in Mesopotamia. They were created using a press of reed styles into wet clay to inscribe wedge-shaped symbols or cuneiform. They served a wide range of purposes, from keeping administrative records, economic record, receipts, ledgers, and legal documents. And there's also literature and religious texts. As some of your religious, you can see like there was the stone tablets that the commandments were written on, and also they were dried in the sun and then they were preserved. So you will say that that was their database where they kept their clay tablets over there, and they will refer to them if they needed to check on records. Then we had Jacquard Loom that we talked about. That's a punch card that I used to in the textile industry. So he was a French who used whenever they were creating textiles, they would have to create them by hand, and it was a long, tedious process. But Jacquard Loom came up with these templates where they will store them, and so each card, a bunch of cards will be laced together into a continuous sequence, and the multiple row holes will be punched on each card, and then each card completed a corresponding row of the design that you wanted. So if you wanted to make a design, instead of doing it from memory or doing it from the expert, you could just create the card that Jacquard Loom invented and then just go over it and over it again. And it took away having to have the expert in there. Then we have the tabulating machine, the Hermann Hollerith God. It came from almost the same concept was the punch cards, but he now made it into where the process of the punch cards were used, but instead he used it to tabulate the census. And so the census used to take about 7 years for those records to be processed. And can someone guess how long it took after Hermann Hollerith came in? Any guesses? From 7 years to how many years? Does anybody have any guesses?
I wouldn't know. Yeah, I wouldn't know. I appreciate you going over the Sumerian records. That was cool to hear you go over that, because that's something that I've actually looked into myself in the past, just wanting to know when, information started getting stored. So I don't know. No.
No, no. All right. So
100 years. 100 years.
no, it was 7 years in the beginning. It was 7 years that they took to tabulate the census data, but they cut it down from 7 years to 1.5 years using the tabulating machine. And you can see, you can only imagine that 7 years, by the time you've tabulated the data, it's not relevant anymore because the population has changed, demographics have changed. So it will be relevant by that time and not as useful. But when the tabulating machine came, it went down from 7 years to 1.5, which is now actually a little bit more usable than 7 years. And so he was also, in regards to the IBM, he created a computing tabulating recording company that later merged with other companies and became IBM. So fast forward, we went down to the file-based data system. The early computers era is about 1950s to 1960s. Used to store data, as you can see back there, in flat files or on magnetic tapes or disks. Access was sequential, and it was hard to search or modify because you can imagine trying to find a place where it's on the tape. And as you can see back there, it was very hard to search for it. It was revolutionary in terms of the storage of the data, because you could store large amounts of data, but the retrieving process was hard as well, because you would have to go through that, and the machines were only a few companies had them, as many people know about the IBM, the mainframes that were used there. So this led to problems like data redundancies and inconsistencies, and came now with what is a database. So we have we used to store data in files when we wrote them. Like whenever you went to your doctor's office, the doctor will probably go somewhere in the basement to look for your records and like, oh, find your records and then come back. And sometimes if you store records that way, it run into problems such as maybe there are rats down there in the basement that will eat the records. Fires will lose all your data on your records on there, and you couldn't keep track of it. So when you think about databases, you can think about storage of your data. And can someone guess where the database icon came from? Anyone? All right, I will let you know. So the database icon, it actually came from the first databases that were created by IBM, as you can see right over there. That was the how they used to store the data on there, and it used to be so huge, and it only stored about 3 megabytes of data, and it was that huge, storing only 3 megabytes. And nowadays we can store a whole lot more data in our devices that can fit in our pockets. So what is a database? If you'll write in the comments what you think the answer is between A, B, C, D, or if you can shout it out. And RJ will tell me if anybody has answered too.
I'm watching the comments. My guess would be D, an organized collection of data that can be easily accessed, managed, or updated.
That's
And the
right.
only reason I'm guessing that is because that's what databases were throughout history, and
That's
reel to reel comes to mind. So Digital D, Diane, my mom, she's not here today, but when she first started getting into this, she was telling us stories how they did the reel to reel, literally
oh
a giant
wow.
reel with tape going across, and it was her job to grab that giant reel, put it up there, transfer it over, and that's how this bank that was keeping all this data would they would keep up with all their clients' information on those reels, and they had a
Wow.
huge storage room of reels, like just
Like
like what
like
you.
those reels back there, like the guy back there on the
Yeah,
reel.
yeah. The
Okay.
the picture that she was painting, and I may be wrong, I wasn't there, but the picture she was painting was that they were a little bit bigger. But looking at I think it's the gentleman back there in the far
Yes.
back corner. Yeah, that's looking about right, and I would like to hear what she would have to say about that.
Wow.
So
Wow.
yeah, that's
And
cool.
you
So
and you can
my
see he
guess
has
was,
reels
go
over
ahead.
there on the table waiting to put them in there to
That's
read them.
right. Yep,
Yeah.
and right below that little table shelf thing looks like they're
They
storing some, doesn't it? Yep.
That's right. Yeah, and
Isn't
they're
that
storing
isn't
some
that
of
crazy? So people went from that to 4 terabytes on this right here. Like,
You're right.
isn't that crazy? So
It is
so
so
my so my
crazy.
my guess is D, just because it seems like it fits.
That's right. Yeah, it's an organizational collection of data that can be easily accessed, managed, or updated. And
Right.
why would we use databases? Like you said, we use them to store data and also organize data and share across applications and users. And it's reliable and secure if you secure it correctly, and easy to search and query. Because if you have good data, you're able to make better decisions and you're able to grow a company. So the databases are everywhere, from like the way you said your mom used to be in banking. There's shopping apps, your contact list on your phone. um, they help keep the track of data in a reliable, secure, and scalable way. That way you do not have to keep remembering things all the time or trying to look for the data, because it's organized. If you organize it well, it's easily accessible, easy for you to access and use that data to make decisions. And let's go into types of databases. We'll start with relational databases. In relational databases, we have examples as MySQL, PostgreSQL, Oracle database, and we're going to go a little bit more into this later on. and see why they're called relational databases. And there's some examples. We have the NoSQL databases, and examples Firebase and MongoDB. And we have in-memory databases such as Redis. And the in-memory databases such as Redis are used by companies, for example, Twitter or X, that they use it to uh, get data quick and to you as fast as possible. We have our object-oriented databases such as ZODB. And then we have what Oracle now has. They say they have a self-driving databases, which are Oracle's autonomous database. They state their databases, and now some of them are autonomous in such a way that they do not rely on a database administrator, and they are using AI to fill in that gap, which is very interesting. And then we have vector databases such as Milvus. Vector databases are usually very important for tools such as AI to use because they store the data in vectors rather than, for example, like relational databases that we store them in tables. And there it is. All right. And we will go now into relational databases. So they're called relational databases because, as you can see in the picture, you can see there's relationships on there. They relate to each other. They have they have been used for a long period of time, and the reason they have their advantages and disadvantages, and we'll start with the advantages of them, is that they have a strong data integrity. They're good for keeping clean data, accurate data, because they enforce things like primary keys, foreign keys, and the system prevents duplicates and invalid references. So this means that the data is more trustworthy, and you do not need to do as many manual checks. As you can see in our pictures over here, we have primary keys and foreign keys where, like, for example, here there's the student with the primary key, but there's when they go to what subject they take, they become foreign key on there because they relate to each other. And this is important because, for example, if you change the student's email, you do not have to go and change the student's email all over where the email is for the student. You just change in the student data, in the student table. And so if you pull that data in the future, for example, if you want to see what course this student takes and their email, you wouldn't have to put the email everywhere, and you won't have to change it, which reduces the time and also the resources to query and also update that data. So they're structured and organized data model. Relational databases, they use tables, predefined schemas. So everything is very structured. They work great when what kind of data you're storing doesn't change as often. And the data analyst and developers can look at the tables and understand the system pretty quickly. Like, as for example, if you look on this one, you can see the advisor to this student on here is right over there. You can visually look at it and understand it from a visual perspective too, and understand it pretty quickly. They have powerful querying capabilities, for example, the SQL, which is SQL query language. And one of the biggest strength is the standard language. It's easy to learn, extremely powerful, and you can combine tables, filter results, run very complex queries with just a few lines of SQL. This makes the relational databases excellent for reporting and analytics. And since we've been using relational databases for a long time, most companies are using their databases to do powerful things with AI because the data is stored and well structured, and they easy to find, not like the way we were doing with the tapes back in the day. Another good advantage for them is that because relational databases have been around for decades, they have very mature tools like performance tuning, backup tools, replication, security features, as well as they've developed over the years. So they're very stable, dependable, and for long-term systems, they're very good. And for the disadvantages of this, they're not ideal for unstructured or rapidly changing data. So if your data structure is changing often, if you're storing things like logs, documents, JSON, things like pictures, they are not very good at that. That's why when we come into the unstructured databases that we saw before, they have scalability challenges too. They typically scale vertically, which means you buy a bigger and bigger server rather than buying. You can scale horizontally, having many machines, but it makes it very complex. So they get expensive and have a physical limit very fast if you have large amounts of data. And so that's why they're not the best option for huge or high traffic systems. They're very good if you're storing data, long-term data that you do not long-term data as well. But when you have high traffic, it becomes the querying is usually slower. For example, like at large scale, the joins that you usually use with SQL, it's the strength, but it's also its downfall because they can become expensive when data sets get very large. When the data sets are very small, they work well. And you have to add indexes to denormalize the data and keep things fast. But when you have large sets of data, they also require more upfront planning because before you create your database and your table, you have to plan your schema before building it because you want to know, for example, we'll look at students. What do we need in the student table? We need the student ID, department name, what credits, GPA, their password. So you need to plan ahead. You cannot just go ahead and put data in there because the data needs to be structured. You have to plan the schema before you building. It's great for stability, but for fast moving teams or projects where data models evolve is not as well. And so they are very good in that data when data is structured, consistent, and crucial, and have good strong querying capabilities, but they can struggle when data is unstructured, scaling requirements are massive, or the schema changes frequently. All right, and we can see SQL basics over here. I have about 4 of them. For example, the first one, it says insert into students. So that's an insert one. And then we have first name, last name, and email. And then we pass on the values, which is Philip Karanja, which is my name, and the email, which is right there. If we did want to select the students, this is select all from the students. We'll get all the students that are in the table. And we can also select all students where the class is biology or department is marketing. So you can query depending on what you want. And you can also delete specifically where customers, like for example, delete from customers where our student ID is that one. But you do not want to do a delete all because you lose all your data. All right, let's now transition from databases to integration. So now you have your database, you have your data, and now you need to use it. So because you can't just store it there forever, it will be of no use to you. So now when you need to use your data, you have to come up with tools to access it. Because as we can see, for example, in this picture, we have your customer on your website. The customer in the website wants to order things. For example, you're on a website, you need to order shoes. So you need to see what shoes this company has. The company needs to find ways to get the data in the database to you so that you can see which shoes you want, what price they are, and how much they cost. And so the customer goes to the website or the customer goes to the mobile app, and then there are APIs. There's the experience API on the first layer, then there's the process API, and then the system API, which talks directly to your data and your databases. So to do this, you can use different types of tools, but today we're going to be talking about a powerful tool called MuleSoft. And MuleSoft takes the grunt work or the donkey work from developers, where the developers don't have to write as much code to attain what they want. So We're going to be seeing how MuleSoft does that, and here in a bit. So this is an example of a MuleSoft flow. So you send the request, your HTTP request. The customer wants to buy shoes, and then go into your APIs in MuleSoft. It goes into your database, and then you get your response back. And we'll see an example of this. And we're going to go into demo. Does anybody have any questions before we proceed?
My only curiosity was what the databases look like today compared to the old pictures that you were showing. But that's something that we're not going to get to see because I think a lot of these are top secret. We don't get to see them. We get to integrate with them, and that's what we're going to get into today. So that
That's right.
my question was off the wall, so don't worry about my question. And you've got nothing in the chat, and that was really good, Philip. Really good job
That
so far. Keep going. You're doing great, man. I appreciate it.
that's right. Yeah, you those databases now we have these big data centers where most data is stored in there, and you don't have those big reels that you feed at your workplace with
Mm-mm.
all your data on there.
I got to see one. While you're getting your demo going, I'll tell you a short story. So in my previous job, I got to go out and I was a firefighter, so we would go to different buildings and just inspect the buildings and make sure they were up to code. And one
Yeah.
of the buildings that we got to go to was an AT&T building, and it was a data center. It was like a main hub where I was near Atlanta, Georgia, and they did not even allow us to go in certain parts of that building. They
Wow.
reassured us. They said everything's, how it should be. Sprinklers are in there, whatever, but we don't even get to go in there. So we can't get you in there because they didn't even have a means to get themselves in. So we said, okay, as long as nobody's in there, we're only worried about the human lives, as long as no humans are ever in there, then we're happy. We'll just not worry about that area of the building. So I
Wow.
didn't even get to see. That was as close as I got to be, and nothing.
My
So
goodness.
all
Wow.
right,
And
I
they're
see
very
Stu.
secure because data is like gold nowadays. Is
Yeah, yeah,
data is what is being used, for example, in AI, because AI becomes better with the more data you have. So
that's right.
they become company secrets.
That's right. AT&T was not playing games. They didn't even have employees that they could trust, much less us. So, all right, you you've got studio going, looking good.
All right. So now we're going to get into a MuleSoft side of things and the integration. So we do have this application called Anypoint Platform over here. The Anypoint Studio. The Anypoint Studio is the application that you use to code with to get your integrations going. So for today, I do have a flow on here. I'm going to show you how we're going to focus on how we're going to interact with the databases. So we do have I have this is what you call a flow in Anypoint Studio or MuleSoft. There's a flow over here, and we do have a listener. And if you were listening, I remember we talked about how you have your requests. So whenever the customer goes in, but today we're going to be using students. So we'll say that when the student comes in to enroll, we do have a path here, which is the enrollment path. As you can see down here, I set our path as API slash enroll. So the request it's listening and waiting for that request. When the request comes in, we're going to press our input, and then here's the databases. So whenever you look here on the right side, we do have what are called connectors, the database connectors on here. The database connectors in your Anypoint Studio, you can bulk delete, bulk insert, bulk update. If you have big sets of data, you can delete, execute DDL, execute strips, insert, select, update. But today we'll focus on selecting and inserting on here. So the beauty about what goes on with MuleSoft is that instead of writing all the XML code, you use the connectors, as you can see on here, and you just drag and drop and connect to your database, for example, right over here. And in my database configuration, as you can see here, I have a database that I spun up, and I connected to it. You have your connections on here. You connected with the URL. You do your user and your password. And where I have my database, I will show you here in the Beaver. Let me pull it up right here. So I have my database running in a container, a Docker container that I spun up. And the way I connected to it through Anypoint Studio was, as you can see, with the username, password, and URL. And now this is a visualization of the database that we have over here. So in our database, we have the tables that we talked about are in the relational databases. We have our courses, enrollments, houses, and the students. So what I did to create this, as we talked about the SQL before, I'll show you here. And if you haven't figured it out, we are doing Hogwarts school right now. We're creating. So we created tables. We have our primary key. This one was for houses. I created another one for students. We have our primary key, first name, last name, house ID, enrollment. Remember, we talked about how you have to define your schema. You have to plan ahead and know what you're going to put in your table. So I went ahead and created my tables. I decided what I wanted in the tables, and then went ahead and created my tables, created the courses, enrollments, and I'm showing you here the SQL. This you can create this using the Anypoint Studio and using Mule, but I'm showing you right now the schema that I use to create them. And then we also have spells on there, and we're going to go ahead and run it, and I'll show you how it works. Right, so Studio is running right now, so it's waiting and listening for me to make a request. I created a small application on here where we're going to be at Hogwarts School of Witchcraft and Wizardry. And we see, let's see, RJ is in here. We're going to sort RJ into a house and get into the sorting ceremony. So the sorting hat is considering over there. And so what happens now is now in the back end of things, a request has been sent in. The request has come in on here, and we've gotten into now the Anypoint platform, where Anypoint Studio, where it was listening to slash enroll, and now it's gotten the information. We've gotten our pay. And let me see, let me back it up. I'll back it up. We'll do somebody else and we'll back it up and I'll show you the data. So what it did now, it passed the input. It went and got all the houses, and once all the houses, all the houses were selected, I have this. I wrote on here. So we're going to randomize where you're being sorted. So it's this. The sorting will be random, so that you can go. It doesn't give you the same house all the time, just like the sorting hat does. And once it sorts, it's going to insert the student into the table, into the students table, and we're going to get a response back. So as you can see right now here, it selected a house. Look like RJ is going to get into Slytherin, and we're going to get a response back. And when we go into our front end of things, I see it's thinking now. It says that you cunning and ambitious, and you're in Slytherin. So as you can see, we had data from the customer side or from the user side, and the user inputs the data. The data is passed on into the listener. The listener listens to it, gets the data, sorts RJ into the house, gets all the houses first, randomizes which house will put in RJ, and then inserts into the database, because we want to keep the data and know where RJ is, because we want to, for future purposes, when RJ goes to class, we can know which house he is. And now we have data set of RJ in Slytherin and his name. And let's do somebody else. Let's do myself. All right, and we'll beginning the sorting ceremony. The data comes in. Now I'm going to show you. So the data will come in. We have first name, which is me, my name, and the last name, which is it comes in as a payload because that's what I put in, and goes one step further. We have our variables here. It changes my name into the variables of first name and last name, and so that we can go ahead and get our payload from the houses. So it gets the data from the houses as a payload. And as you can see right on here, we have the payload. We have Gryffindor, Hufflepuff, Ravenclaw, and Slytherin. So we've gone into our databases and gotten all the houses that are available in there. And I will show you also, we can look at the data, make sure that it's not lying. See right over here, it's gone in and gotten all the house names that are in there. And we've retrieved them. And then after we've retrieved them, we randomly selected which house on there. Oh, there we go. We randomly selected which house we're going to put me into. And we came inserted in there, and we're going to look at that. And looks like I'm in the same house as you. Looks like I'm going to be in Slytherin as well. All right. All right. So that ends my demo today. Thanks. And does anybody have any questions for me?
So I noticed that you're getting your answer, you're getting your feedback in Anypoint Studio before you're getting it over here on the website where you're showing right now.
That's right.
Maybe, yeah, just kind of explain that because I mean, I'm sure it's probably has something to do with what's going on behind the scenes and how it's getting sorted out, and then it brings it out here. But
Yeah.
yeah, just go
So,
into that.
so the logic I did when I was sorting the house is what happens is when it gets the house name back, it comes in and depending on the house that you've been chosen into, it pretends it's thinking. And what the thinking is, for example, if you're slithering, it starts talking like you're cunning and ambitious. You'll use any means. So depending on what house comes back from the Anypoint Studio, it'll start showing the thinking. So it pauses for a while and starts doing the thinking depending on the house, and
That's what
then
I
give
like.
answer.
I
Yes,
like seeing that. I like seeing the behind the scenes, how it's processing, and then it brings it out to the customer, to the client, whatever. You know,
that's right.
I may make some people sad in the room. My apologies. I don't know anything about all the Hogwarts, or is it Harry Potter? Is that where that
Yeah,
comes from? Okay,
that's
I've never gotten into any of it, but so I'm just like processing the what's taking place here. So that is cool. That's cool to see how you can process this through, and then the client facing is going to finally see that answer come through. Really cool.
that's correct. And as you can see, I've logged the messages that come back from Studio. So the API response comes back here and says enrollment successful, which is what's coming back from Studio. And then I just isolate the name and the house, and then show back those two, and with the message now, welcome to Slytherin with the house. So
And you can
Studio,
make it be anything. Like Ryan said, Ryan's saying in the chat, insert into houses the value of IQ. So put integration quest as a house. So there
that's
you
right.
go. That's an option. Yeah, that's cool. I like it.
That's correct. Yeah, you can put anything that you want into there. And I'll also show you, let me go back into dbeaver here. Like for example, this is how I created the houses. You can say insert into houses. This is how I create the houses. So for example, you can do integration quest, and then you can put the founder. And I don't know what the integration quest animal will be, the animal mascot.
Hey, I think it's It's something. What is it, Ryan? What's the Integration Quest mascot? It's not been sorted out yet, so maybe to be announced.
Yeah, we're actually we're working on a mascot right now, actually, but it's not an animal. It's not an animal, so we'd have to change the name of the column.
There you go.
And you can see that's one of what I was talking about. The disadvantages is that you have to plan your data ahead of time, because now if it's not an animal, you'll have to think about what column will we have now and change it over there. So you have to think before you create the tables and you have to think about what your schema will be.
Absolutely, very good.
Our color scheme would be unique, at least. I'm looking at those color schemes. None of those are ours.
That's right. It was a blue.
I like the clay tablet, the history of data. That was great.
Yeah, I feel like before you know where you're going, you need to know where it came from. Like it was built brick by brick slowly, and now we have databases. And like RJ said, you can't even get in there. They're so secure, hosts a lot of data. Yes.
To go from the Sumerian records to where we are now, yeah, that's a huge jump. It's amazing to see that. That's always interested me.
Yes. All right. And that's it for me, unless anybody has any other questions.
That's awesome. Very good. Yeah, if anybody has any questions, feel free to ask. We went through a lot of information, and I like seeing how things work.
That's right. Yeah, once you know how things work, you are able to understand things better and utilize them better.
Absolutely.
That's right. Okay, thank you so much.
Yeah, definitely. If you'll stop sharing, I'm going to share a final thing here. And again, thank you, Philip, so much for coming in today. We really appreciate you coming and presenting and sharing with us on data. The final thing that I had to show is a sneak peek to next week. So we've got Digital D. Diane's going to be coming back in here. She's going to be giving a presentation on what you see right there, hyperautomation with Salesforce, Einstein, and MuleSoft. So y'all make sure you come in for that. That's going to be happening on Friday of next week. I'll be sending out some emails, but you've already got the information right there. And so count on that happening. And again, thank you so much, Philip. Thank you, everybody, for coming and joining and participating. We really appreciate it. And I'm going to stop the recording, and we'll see you all next time.
Okay, thank you so much.
Yeah, great job.
Thank you.